Good evening everyone. Good evening. Welcome back to NEET Elite. What's up guys, how are you doing? If I'm audible and visible to everyone, let me know in the chat box with the thumbs ups. Well, Yashwant has come up with the quote. If you cannot fly, they run. If you cannot run, then walk. If you cannot walk, then crawl. But whatever you do, you have to keep moving forward. Oh, wonderful bro. Exactly. Yes, fit hoti aap log bhai. People, if I'm audible and visible to everyone, let me know in the chat box. Let me know in the chat box with the thumbs ups. Yes. Hi, Yashwini. All right. हाँ जी अक्षता हो जाएगा, टेंशन ना लो आप, अभी टाइम अपने पास बहुत. All right, so people, well, this is going to be the last session from the chapter Chemical Kinetics. And in this session, we are going to talk about the kinetics of reversible reactions. And at the end, we'll be talking about the Arrhenius equation and the questions which are related to the Arrhenius equations, right? Nidhi, I'll let you know which chapter is going to be next. Let me finish it off first, yeah? Okay, so people, before starting the session, let me introduce myself. As you must be knowing now, my name is Wassim Sir and I'm your chemistry master teacher right here. Okay? Well, people, for the ones who have no idea about the NEET 2021 crash course, which we are starting on the actual Vedantu platform, what all benefits you guys are going to get if you'll enroll yourself in this NEET 2021 crash course. Let me tell you, we are going to cover your whole syllabus before your NEET 2021, right? And it's going to be your wish to select the teachers in your physics, chemistry, as well as biology, right, in this crash course. At the same time, guys, it's not only about the syllabus completion right here in this crash course. There will be test series, there will be mock tests, everything will be included right here. And by means of that mock test series, you can compare your ranks with the other students across the country, right? And absolutely, there will be some extra sessions by the experts, right, who will be showing you how to solve the questions in lesser time. Yes, and at the same time, there will be some extra sessions on the time management as well. And at the same time, it's going to be a two-way learning interactive platform wherein you can ask the doubts anytime to your master teachers. Yes. Okay. So people, how to get enrolled in this crash course right here? You just have to click on the Vedantu app. After clicking on the Vedantu app, just click on NEET Crash Course, and after clicking on NEET Crash Course, what you guys will be doing is you just have to use the code as WSCC if you want me to be your mentor in the crash course. Okay, use the coupon code WSCC. After using this coupon code, what you guys are going to get? You'll be getting the 20% off. Yeah, and after the 20% off, you guys are just getting this crash course for 8K. Okay, so the next batch, it started today, yes, and the next batch will be starting in the coming week, right? The link is there in the description box of the video. I want you guys to click on the link, get enrolled to it, okay? And let's meet up in the actual Vedantu platform, yeah? Okay. All right, so people, one more news for you. That is the NEET 2021 test series. If you're not willing to take the crash course, then we have come up with one more plan for you. That is just for test series, right? Just for test series, right? So in this, what you guys will be doing is, we are going to conduct the test series, which is going to be, in the all India level, yes? Okay, so people, what is there in this test series? There will be 20 tests around, there'll be 20 tests, and after every test there'll be the discussion, right? Test paper discussion after every test will be there, like everything is there. Okay, if you think you've got a good preparation, you can just enroll for the test series, which is just affordable, like 2K after using the coupon code WSCC, right? Okay, so just see whatever plan is best for you, you can go for it, right? Okay, and it's not only going to be the normal test series, like you just have to write the exams. There will be the discussion on the test paper as well in all the three: physics, chemistry, as well as biology, right? Okay, the link to get this test series is there in the description box. You can click on the link and get added, yeah? Okay, so for the ones who have not liked the video yet, do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions, yes? All right, so people, these are the two topics which we are going to cover in the tonight's session, which is going to be kinetics of a first order reversible reaction, and at the same time we are going to talk about the Arrhenius equation. Let me know in the chat box if you guys are super excited for the session. Let me know in the chat box if you guys are super duper excited for the session. Yes. Calvin is super excited. Yes. Nivetha is always ready for the session. Is that? Shakir is super excited. Darshini is super excited. Wonderful. That's great. So people, without wasting a lot of your time, let's get started with something called as kinetics of a first order reversible reaction. Okay. These are two important topics from which questions have been frequently asked. Okay. Right? That's great. That's great. That's great, Kalpana. That's great. Alright guys, so let's start with something called as kinetics of a first order reversible reaction, okay? So first of all, what is a reversible reaction all about? As you all must be knowing, we have studied these reversible reactions in detail in the chapter Chemical Equilibrium, yes? And in that chemical equilibrium, how did we define reversible reactions? Simply, reversible reactions are the ones which can proceed in forward as well as backward direction, yes? Any reaction which can proceed in forward as well as backward direction, that's what we call as a reversible reaction. And how do we represent these reversible reactions? It's very simple. I just represent the reversible reaction by these two arrows, yes? So these two arrows say that the reaction is reversible. It can proceed in forward as well as backward direction, right? Well people, since it's a reversible reaction, when should I be calling it as first order reversible reaction? No doubt, we know it's a reversible reaction. It can proceed in both the directions, forward as well as backward. Now the point is, when can I call this as the first order reversible reaction? Understand. Let's say the rate constant for the forward reaction is Kf. Let's say the rate constant for backward reaction is Kb. If I'll ask you, is this actually a single reaction or these are actually two reactions? I think these are two reactions, yes? Forward and then backward, yeah? Let me write the steps which are involved in this reaction. The first step is going to be the forward reaction, A gives B, right? For which the rate constant is Kf. The next reaction is going to be the backward reaction in which B gets converted to A, for which rate constant I'm representing by Kb, yes? These are the steps which are involved in this reversible reaction right here, yes? Now, I'll be calling this reversible reaction as the first order reversible reaction if the steps involved in this reversible reaction are of the order 1. So this step should be first order and this step should be also first order. Then only I can call this reversible reaction as the first order reversible reaction, okay? Right? People, there is one more name for it. I can call this kinetics as a first order reaction. I can call it as the first order reaction. First order reaction opposed by a first order reaction. I can call it like this as well, right? Because the forward reaction is first order, backward reaction is first order, yes? So I can say it is a first order reaction opposed by the first order reaction, right? Okay, now what all things do we need to know about this reversible reaction, about this first order reversible reaction? Let's get to know that. I'm not going to derive any sort of expression tonight, okay? I'll be just giving you the expressions and I'll show you the application part, I mean how to use those expressions in the questions, right? See guys, have a look. Let's say at time t is equal to 0, the concentration of reactant or the moles of reactant are represented by A. Let's say at time t is equal to 0, I have got A moles of reactant, or I can say, let's say at time t is equal to 0, the concentration of reactant is A, yeah? So what is going to be the concentration of product? It's going to be 0 at time t is equal to 0, right? Now what is going to happen? Let's say at time t, out of A moles of reactant, let's say X moles have got dissociated into products, right? So at time t, I'll be left with A minus X moles of this reactant right here. Similarly, 1 mole gives 1 mole. Since I'm assuming this as the balanced chemical equation, if 1 mole gives 1 mole, so X moles should give X moles of product right here. So at time t, I have got A minus X moles of reactant and X moles of product, right? Now people, since it's a reversible reaction, right? So there'll be a time when equilibrium will be established in this reaction. And for example, at equilibrium, for example, when equilibrium got established in the reaction, let's assume at that time, out of A moles of reactant, XE moles of reactant have got converted into products. So I'll say I'll be left with A minus XE moles of reactants at equilibrium, right? What is this XE? XE, these are the moles of reactants which have dissociated into products at equilibrium, correct? Now, if I ask you how many moles of products will be there at equilibrium, I'll say 1 mole gives 1 mole, so XE moles should give me XE moles, right? So this A minus XE, these are the moles of reactant left at equilibrium. These are the moles of products left at equilibrium. Or I can talk in terms of concentration as well. I can say this is the concentration of reactant at equilibrium. This is the concentration of product at equilibrium, right? This is something which I know till now, correct? Now people, directly I'm going to give you one expression. Directly I'm going to give you the integrated rate equation for this reversible first order reaction, okay? Then I'll show you how to apply that equation in the form of questions, right? Okay, so people, my equation is going to be Kf plus Kb, where Kf is rate constant of forward reaction, rate constant of backward reaction. Kf plus Kb is 2.303 divided by T. This is going to be log of Xe divided by Xe minus X. This is what I call as integrated rate equation for the reversible first order reaction. You have to be just careful with the terminologies which I have used right here. You just have to see the terminologies, just right? What is Kf? What is Kf? Kf is what we call as rate constant for forward reaction. Kb is what we call as rate constant for backward reaction, right? What is T? T is the time taken by the reactant to change its concentration from A to A minus X. Yeah, this Xe, this is the concentration of reactant which got converted into products, right? At equilibrium, because I'm writing Xe. What is this X? This X, this is the concentration of reactant which got dissociated at time t, or I can say these are the moles of reactants which got dissociated at time t, right? Correct? You just have to be careful with the terminologies. That's it. That's all I want. Okay. Now I'll directly show you how to use this equation in the questions, right? There have been questions asked from this topic as well. So let's get to know how the questions can be asked from this. Okay. And I'm going to take the questions in which more than one concept will get involved, right? Let's get started. Let's get started. This is the first question on your screen, guys. This is the first question on your screen. You can easily solve it. You can easily solve it. Understand? I'm given with a reversible first order reaction. I'm given with a reversible first order reaction. Okay. How I got to know that it's a reversible first order reaction? Since the unit of rate constant right here is second inverse, right? The unit of a rate constant of forward reaction is second inverse, so I'll say the forward reaction is of the order 1. Similarly, backward reaction is also going to be the order 1. I'm given with the initial concentration of reactant as well, and I'm assuming initial concentration of reactant equal to the initial moles of reactant, right? I'm given with the terminology concentration of B at equilibrium divided by concentration of A at equilibrium is equal to 4. Okay, fine. Then calculate the concentration of B after 30 seconds. This is something which I'm supposed to calculate, right? Let's see how these sort of questions are to be solved. Understand? See, guys. First of all, I'm going to write the reaction as A. This is B. Yes. Rate constant for forward reaction is K1. Rate constant for backward reaction is K2. Correct? Let me write the terminologies again. Let's say at time t is equal to 0. I have got A moles of reactant. This is going to be 0. Correct? At time t, let's assume X moles of A have got dissociated. So I'll be left with A minus X moles of reactant at time t. Similarly, X moles of product would have got formed at time t. Yes. Now at equilibrium, I'm assuming out of A moles of reactant, Xe moles have dissociated. So I'll be left with A minus Xe moles of reactant at equilibrium. Similarly, Xe moles of product would have got formed at equilibrium. Yes. Now people, there are certain parameters which are given to me. Understand these parameters. Understand properly. People, I hope you remember equilibrium constant. How do we define it? Equilibrium constant is nothing. It is equal to rate constant for forward reaction divided by rate constant for backward reaction. Yes. The ratio of rate constant of forward to the rate constant of backward reaction is how we define equilibrium constant. I hope you remember that. Yeah. So equilibrium constant right here is going to be simply K1 divided by K2. Yeah, I can say that. At the same time, guys, how do I write the expression for equilibrium constant for this reaction? Isn't it going to be concentration of B at equilibrium divided by concentration of A at equilibrium raised power the stoichiometric coefficients, which are 1 and 1? Yeah, that's how we write the equilibrium constant expression. I hope you remember this as well. People, at the same time, this concentration of B at equilibrium divided by A at equilibrium, it's given to me as 4. Yeah, it's given to me as 4, correct? This is something which I know. Now from all these terms, I'm going to take these two terms. I'm going to take these two terms. What can I get from here? What can I get from here? Can I say I'll get the value of K2 by equating these two? Yeah, right? So I can say something like this. Instead of K1, I can write 10 power minus 2 divided by K2 is nothing. It is equal to 4. So I can get the value of K2 from here. It's going to be 10 raised power minus 2 divided by 4. It's going to be 0.25 multiplied by 10 power minus 2 second inverse. I got the value of K2, right? K2 I got. K1 I already have. Okay. Now what else I need? What else I need? See guys, few minutes back I told you. See, I can just equate it to one more thing. What is the concentration of B at equilibrium? The concentration, the moles of B at equilibrium is Xc. What is the concentration of A at equilibrium? Concentration of A as well as moles of A at equilibrium, I'm assuming as A minus Xc, right? I'm taking concentration equal to the moles, right? Okay, I'm assuming the container in which the reaction takes place, its volume is 1 liter. So concentration is going to be same as moles, yeah? Okay. So people, instead of concentration of B at equilibrium, should I be writing something like this? Xe divided by, it's going to be A minus Xc, yes? So I'll get, just cross multiply these two things. I'll get 4A minus 4Xe is equal to Xc. So from here, I'll be getting the value of Xc as 4A divided by 5. Yes, this is something which I got. Right? Now people understand. What is this A? A is what I call as initial moles of reactant, or I call this as initial concentration of reactant. Initial concentration of reactant is given as 0.01. So I got this 4 multiplied by 0.01 divided by 5, or I'll get the value of Xc right here as 0.04 divided by 5, which is simply going to be 0.008, right? This is the value of Xe at equilibrium. These are the moles of products which have got formed at equilibrium, right? So I got everything, whatever parameters I needed in order to write in the integrate rate equation. I got all the parameters. Now let's try to use these parameters. Let's get to know what is the concentration of B left. What is the concentration of B after after how many minutes? Okay, after 30 seconds, right? So I'm supposed to check after 30 seconds, what will be the concentration of B? That means I need to get the value of X, right? I need to get the value of X. I need to check after 30 seconds, what is going to be the concentration of B? After 30 seconds, what are going to be the moles of B which have got formed in the reaction? Yes? Let's get to know how to solve this afterwards. Yeah. See guys, I'm just erasing this part. I hope this is clear. Yes, I just need the values. K2 I have got as this one, and Xe I have got as 0.008. Okay. Now guys, let's try to use the integrated rate equation. That used to be equal to Kf plus Kb, but instead of Kf plus Kb, I'll be writing simply K1 plus K2, right? It's going to be 2.303 divided by T. It's going to be log of Xe divided by Xe minus X. Yeah. I think I have all the parameters with me. I just have to put all the parameters into this equation. Yeah. Have a look, guys. K1 value, I already know that is 10 power minus 2. Plus K2 value, I got to know that is 0.25 multiplied by 10 power minus 2 is equal. It's going to be 2.303 divided by T. What is T given to me? T is given to me as 30 seconds. Yes, because I need to check the value of X at time T is equal to 30 seconds. It's going to be log of Xe. I think Xe value I know already. Yeah, Xe value I know already. I got that. Divided by Xe minus X. Correct? So people just have a look in this equation. In this equation, I've got all the parameters except X. Now it is just the calculation part left. Right? So over here, if you take 10 power minus 2 common, it's going to be 1.25 multiplied by 10 power minus 2. Yes, It's going to be 2.303 divided by 30 is going to be log of XE. XE value I got to know as 0.008 divided by XE is 0.008 minus X. Yes, this is something which I got. This is something which I got right here. People, in this equation, can I say there is only one variable, that is this one? Yes. Can we solve this and get the value of X from here? And whatever is the value of X, that is going to be the concentration of B formed after 30 seconds. Remember, in your exam, your calculation part is going to be easy, but concept can be same. Calculation part is going to be very, very easy, but the concept is going to be same. Well, Arzu have come up with the answer. She is saying X value will be getting from here as how much? 0.0036. All right, 0.0036 molar is going to be the concentration of product formed after 30 seconds, right? Correct. Let me know in the chat box if you got it. People, the calculation part in your exam is going to be easy, but the concept asked can be same, okay? Let me know in the chat box fast now if it is clear to every single guy so that I can move on to the next question, yeah? Let me know fast. Yes. I want every one of you to say it. Wonderful. Let's move on to one more question, guys. Okay. This is one more question which is on a screen right here. Correct? We have got a reaction in which cis isomer is getting converted into trans isomer. Rate constant of forward reaction, rate constant of backward reaction is a first order reversible reaction. Kf value is given, equilibrium constant is given. Then calculate the time for the half of the equilibrium concentration of trans isomer to be formed. Okay, calculate the time taken for half of the equilibrium concentration of trans isomer to be formed. All right, let's kill this one as well. See, I'm good with the reaction. I'm not going to write this cis and trans. I'm just going to write a common reaction as A, B, right? Where we know A is the cis isomer and B is the trans isomer, right? Kf is the rate constant for forward, Kb is the rate constant for backward. Yes. Yes. Now people, we know at time t is equal to 0, let's assume I have got A moles of this reactant, this is going to be 0. At time t, let's say out of A moles, X moles have got dissociated into products. So I'll be having A minus X moles of reactant left with me, and there are going to be X moles of product at time t, right? Now similarly guys, at equilibrium, can I say out of A moles, Xe moles have got converted into products, so I'll be left with A minus Xe moles of reactant, yes, and similarly Xe moles of product would have got formed, yes. Now what am I supposed to check actually? Calculate the time taken for half of the equilibrium concentration of trans isomer to be formed. This is my trans isomer, right? We need to check at what time the concentration of product is going to be exactly half of the equilibrium concentration. That's something which I need to check. At what time the concentration of product is going to be half of the equilibrium concentration. This is what I'm supposed to check right here. Yeah. Now we will see. How I'll be solving this question. Understand? I'm given with something as equilibrium constant is given to be as 0.1, and we know equilibrium constant is nothing, that is Kf divided by Kb. Its value is given to me as 0.1. People, am I given with something? Yes, I'm given with Kf value. Yeah. So Kf value is given to me as 3 multiplied by 10 to the power minus 4 divided by Kb is equal to 0.1. So from here, can I get the value of Kb? It's going to be 3 multiplied by 10 to the power minus 4 divided by 10 to the power minus 1. It's going to be 3 multiplied by 10 power minus 3. I got the value of Kb. I have the value of Kf as well. Yes. Now it's done. Yes. It's done. The question is dusted. I'll be simply using the integrated rate equation. That's going to be Kf plus Kb is equal to 2.303 divided by T. It's going to be log of Xe divided by Xe minus X, as I already told you, yeah? So people, am I given with the value of Kf? I got the value of Kf, right? It's given in the equation. Do I have the value of Kb? Yes, I got the value of Kb as well. We need to calculate the value of T. Yes. And this is going to be Xe divided by Xe minus X. Instead of X, can I write Xe by 2? Yeah. Instead of X, I'm writing Xe by 2, correct? Yes. So people, if I take Xe common in the numerator and denominator, I can say Xe will get cancelled everywhere. So Kf value is given to me as how much? Kf value is given to me as 3 multiplied by 10 to the power what? 3 multiplied by 10 power minus 4 plus Kb value I got to know as 3 multiplied by 10 to the power minus 3. Yes, it's going to be simply equal to 2.303 divided by t. It's going to be log of xe is gone. It's 1 divided by 1 by 2. That means log of 2. Yes. So this is something which I'm supposed to calculate. Can you let me know the exact value which you'll be getting from here? Or you can solve it out afterwards, right? I told you in the beginning, guys, calculation part is going to be easy in the exam, but concept can be same, right? You'll be getting the value of t right here as 210 seconds. So people, what does this t is equal to 200 seconds mean right here? I can say simply after 210 seconds, the concentration of B will be equal to the half of the equilibrium concentration. So after 210 seconds, what you'll observe the concentration of B exactly to be half of the equilibrium concentration. Yes, that's what we were supposed to calculate. Let me know in the chat box if it's clear to every single guy right here. Let me know in the chat box. Till then, I can have some water. Let me know in the chat box, guys. Okay, should we move on to the Arrhenius equation now? Should we move on to the Arrhenius equation now? Yes. All right, let's get started with something called as Arrhenius equation. What this Arrhenius equation is all about. See guys, again a very simple topic, okay? Just need to remember a few things, yeah? Just a second, guys. Okay. Let's assume I've got a reaction as A gives B. Let's say this is the reaction which is given to me. Let's say its rate constant is K. Let's say its rate constant is K, right? Its order is anything. It's nth order reaction, right? Okay. Now, I actually need to check what will happen to the rate constant. I actually need to check what will happen to the rate constant on changing the temperature of the reaction. Actually, Arrhenius equation, it gives me the effect of temperature on rate constant. Yeah. Arrhenius equation gives me the effect of temperature on rate constant. As per Arrhenius equation, I'll get to know whether rate constant will increase or decrease on changing the temperature. And how will I be getting to know that? See, as per Arrhenius equation, guys, I'm going to give you the equation directly. As per Arrhenius equation, K, rate constant is equal to E to the power minus EA divided by RT. This is something which we call as Arrhenius equation, right? Now, what these parameters right here are? This K is what I call as rate constant of the reaction. A is the pre-exponential factor, right? A is the pre-exponential factor. It is the pre-exponential factor. Correct? What is this EA? EA is what I call as activation energy. I hope you know that. It's what we call as activation energy. And people, this A and EA collectively are called as Arrhenius parameters. Yeah? Correct? Now, as per Arrhenius equation, we'll get to know what is going to happen to the rate constant, what is going to happen to the rate of reaction, yes, on changing the temperature, yes. Now, guys, see, if I write the rate law for this reaction, it's going to be R is equal to K multiplied by concentration of A to the power, let's say order of this reaction is N, okay, to the power N, okay. Now, what I'll be doing right here, I'm going to erase all this. I hope you would have copied all this down, yeah. I hope you would have copied all this down. Now, people, see what all things can I conclude from here. See, first thing, this is the reaction which I have right here. If I'll increase the temperature of this reaction, people, if I increase the temperature, can I say the value of EA divided by RT will decrease? Yeah. I'll simply say on increasing the temperature, the value of EA divided by RT will decrease. Yeah. If the value of EA by RT is decreasing, can I say the value of minus EA divided by RT will simply increase? Yeah. Okay. Now, if the value of minus EA by RT is increasing, can I say something like this? E to the power minus EA divided by RT, this value will increase. Yes. Yes. Right? Now we will have a look. If this value is increasing, can I say A multiplied by E to the power minus EA divided by RT will also increase? Yes. I can say that. Now we will, what is this term actually? This is rate constant, right? So I will say simply rate constant of the reaction will increase. Rate constant of the reaction will increase. So in general, on increasing the temperature of the reaction, what is happening to the rate constant of the reaction? Rate constant is increasing. Yes. And if the rate constant is increasing, I'll say rate of reaction will increase. So I can generalize a simple statement right here. On increasing the temperature, rate constant of a particular reaction increases, hence rate of reaction increases. Yes. So remember, on increasing the temperature, what happens to the rate of reaction? Rate of reaction actually increases. Yeah. Now. There are few more things which you must know about this Arrhenius equation, okay? And those forms of Arrhenius equation, from those forms questions have been asked in your competitive examination as well, okay? What are those parameters going to be? Understand. Let me erase this part. I'm sure you would have noted everything down, yeah? Let me erase this part right here, okay? See guys, I got to know your Arrhenius equation K is nothing, that is equal to A e to the power minus EA divided by RT. This is something which I know. Yeah, this is something which I know as per Arrhenius equation. Now what I'll be doing right here is, I'll be multiplying throughout by ln. It's going to be ln of K is equal to ln of A e to the power minus EA divided by RT. Now it's ln of M into N. What's that going to be? That is simply going to be, by using normal mathematics, it's going to be ln of A plus ln of E to the power minus EA divided by RT. Yes. Now people, it's simply going to be ln of K is equal to ln of A. This term will come to the front. It's going to be minus AA divided by RT. And ln of E to the base E, as we all know, that's 1. Yeah. This is something which I got till now. This is first form of the Arrhenius equation which I got. Yeah. Now people, I can do the same thing in terms of log. And we know how do we convert ln into log. Yes. See guys, I'll be using this equation. Instead of ln K, I'll be writing something like this. It is 2.303. It is log of K to the base 10 is equal. Instead of ln of A, I'll be writing something like this. 2.303. It's going to be log of A to the base 10 minus EA divided by RT. Yeah. Now in this equation, if I'll do a simple thing, I'll divide throughout by 2.303. Can I say I'll be getting an equation like this? Log of K is equal to log of A minus EA divided by 2.303 RT. Yes, this is one more equation which I got in the logarithmic form as per your Arrhenius is concerned. Yeah. Yes. Now people, it's high time to plot few curves. Yeah. Let's plot few curves as well about this Arrhenius. So let's try to plot the first curve between ln of K versus 1 by T. Yeah. Let's try to plot this curve, ln of K versus 1 by T. What's the equation which I have? I have equation right here as ln of K is equal to ln of A minus EA divided by R. I can write it as 1 by T. Yeah, I can do that, correct? Now people, along y-axis I'm plotting ln of K. Along x-axis I'm plotting 1 by T. Instead of ln of K, you are going to write y is equal to. Instead of 1 by T, you are going to write x. And this whole term is your slope m. Over here the sign is negative. Instead of ln A, you are going to write c. Y is equal to minus mx plus c. That means curve is a straight line like this with a negative slope. What about slope of this curve, guys? I'll say slope of this curve is simply minus EA divided by R. Yeah. It is minus EA divided by R. If I ask you what is going to be the intercept right here, intercept is the value of C, which I got as ln of A. This is the first curve which I got, yeah. This is the first curve which I got. Similarly, I can plot one more curve right here, and that curve is going to be between, it's going to be between log of K to the base 10 with 1 by T, yeah. Now people, the equation which I got right here, can I write it like this? I'll remove this T and I'm going to write 1 by T like this. Now it's fine, yeah, I can do that. People, this log K I'm plotting along y-axis, this 1 by T again I'm plotting along x-axis. So instead of log K, what I'm writing, I'll be writing y. Instead of 1 by T, I'll be writing x. And this is going to be m, this is minus, this is c. Y, again, y is equal to minus mx plus c. Again, it's going to be a straight line with a negative slope. And if I ask you what is going to be the slope of this curve, you'll simply say slope right now is going to be minus e divided by 2.303 r, yeah? So slope right here is going to be minus e divided by 2.303 r. So the difference lies in the slope between these two curves. In that curve, the slope was minus e by r. In this curve, the slope is going to be minus e divided by 2.303 r. Yes. At the same time, if I ask you what is the value of this C intercept, intercept C means this log of K. Yeah. Over here in the curve which I made already, what was the intercept? That was ln of A. Over here, the intercept is log of A to the base 10. Right? These are a few basic things which I want you guys to take a note of. Number one. Okay. Number two. Number two, guys, have a look. Number two. Let's say I've got a reaction like this. A gives B. Correct? Its rate constant is K. Its rate constant is K. Or let me write it like this. Let's say when the temperature of this reaction was T1, its rate constant was K1. And let's assume I'm changing the temperature of the reaction. I'm changing the temperature of the reaction from T1 to T2. And right now we got to know on changing the temperature of the reaction, the rate constant of the reaction changed from K1 to K2. Yes. Correct. Now people, if I write the logarithmic form of Arrhenius equation at temperature T1 and at temperature T2, what I'll be getting? Understand. I'll write something like this. I got the equation log of what? I got the equation log of K, I hope you remember, log of K is equal to log of A minus EA divided by 2.303 R multiplied by T. This is something which I got few minutes back, yeah. Now, if I write this equation at temperature T1 and temperature T2, what I'll be getting? Say, at temperature T1, the value of rate constant is K1. So I'll be writing something like this. It's going to be log of K1 is equal. It's going to be log of A minus EA divided by 2.303 and it's going to be RT1. Yes, it's going to be R and it's going to be T1 right here. Yes. Similarly, guys, I'll be writing like this. Log of K2 at temperature T2, I'm writing log of K2 is equal to log of A minus EA divided by 2.303 and it's going to be R, it's going to be T2. Yes, I got two equations right here. Correct? Yeah, let's call this as equation number 1. Let's call this as equation number 2. If I'll subtract the both, if I'll subtract first from second, I'm subtracting first from second. What I'll be getting? Log of K2 minus log of K1. Isn't it going to be log of K2 divided by K1? Yes, will be equal. I'm subtracting first from second, right? This will be minus, this will be minus, this will be plus, yes? And this term got cancelled out, right? So it's going to be log of K2 minus log of K1 is going to be log of K2 by K1. Now people, it's going to be, I'll take EA divided by 2.303 R as common, right? It's going to be 1 divided by T1 minus 1 divided by T2. Yes, this is one more expression which is really, really very important, which I'll be frequently using in the questions. Yeah. Right? So a lot of expressions I got till now for the Arrhenius equation, right? Yes. People, is it clear till here? Is it clear till here? Let me know in the chat box if everything is clear till here so that I can move on to the questions. Yeah, before going to the questions, I need to tell you one more form of it, right? Which is frequently asked as well. See guys. If we'll have a look on one more form of this Arrhenius equation, have a look. Understand. Let me erase all this right here. Okay. If you remember your zero order reaction, in your zero order reaction, if you remember, half-life used to be equal to A0 divided by 2K. For the zero order reaction, yeah, I hope you remember that. For the first order reaction, half-life used to be 0.693 divided by K, correct? People, if you will take any order reaction, remember half-life is always going to be inversely proportional to K. Remember, if you take any order reaction, half-life is always going to be inversely proportional to the rate constant K. Yeah? Correct? Now people, I'm going to write one thing. I can write half-life of the reaction at temperature T1 divided by half-life of the reaction at temperature T2. Isn't it simply going to be K2 divided by K1? Half-life of the reaction at temperature half-life of the reaction at temperature T1 divided by half-life of the reaction at temperature T2 is always going to be equal to K2 divided by K1. This is something which I got, correct? Now people, instead of this K2 by K1, I can write it in the form of half-life as well, yeah? Right? Now we will see what I'll be writing. See, instead of log of K2 by K1, what I'll be writing? I'll be writing log of, instead of K2 by K1, I'll be writing half-life of the reaction at temperature T1 divided by half-life of the reaction at temperature T2. Now it's going to be EA divided by 2.303 R multiplied by 1 divided by T1 minus 1 divided by T2. This is something which I got till now, yeah? This is one more expression which I want you guys to take a note of, yeah? Correct? Is everything clear till here? Is everything clear till here? Right? Everything is clear till here so that I can move on to the questions. I hope it's clear. Let me know in the chat box. Let me know in the chat box. Thank you, Yashwan, thank you. Bro, I have left biology in class 10, so I have no idea what this adenosine triphosphate is all about. Is that ATP? something, yeah. Like everything is clear till here? Should we solve some questions now? Okay, fine, great. Let's move on to the first question. Let's see what it's all about. Okay. Calculate the activation energy of the reaction. Number 1 in kilojoules per mole, number 2 in kilocalories per mole. And we are given with something like this. Okay. People, just have a look on this curve. I think we have made this curve a few minutes back, yeah? We have made this curve a few minutes back between log K versus 1 by T. What used to be the slope of this curve? I hope you remember. Slope of this curve used to be minus EA divided by 2.303 R. Yeah, it's log of K versus 1 by T. Yeah. Okay. Now guys, have a look. What are we supposed to calculate? We are supposed to calculate activation energy of the reaction. People, have a look. If I want to calculate the slope of this curve means tan of theta. Since if this angle is theta, right? Slope of this curve means the angle, first of all, the angle which the curve makes with the positive x-axis in anti-clockwise direction, that is theta. I just need to take the tan of this theta, that will give me the slope of this curve, yeah? So slope of this curve is nothing, that is equal to tan of theta. Correct? We know, it's given in the equation, theta is equal to tan inverse minus 3. So if I take this tan inverse on this side, is going to be tan of theta is equal to minus 3, yeah? Correct? Or I can do one thing, just multiply throughout by tan. It's going to be tan theta is equal to tan and tan inverse gone. Tan of theta is equal to minus 3. And instead of tan theta right here, I'm simply going to write minus 3. So minus 3 is equal to minus EA divided by 2.303 R, which I got. Yes. Now, it entirely depends on the value of R. The value of R which you'll be taking, entire activation energy is going to depend on that. Yeah. How? Have a look. I'll say EA is equal to 2.303 multiplied by R multiplied by 3. Yes, minus is gone. EA is equal to this multiplied by this, correct? Okay. Now first thing, I need to calculate the value of activation energy in kilojoules per mole. That's what I need to do. Yes. See guys, what I'll be doing. I'll be writing activation energy is equal 2.303. If I take the R value as 8.314 joules per Kelvin per mole, I'll say this whole value will be in joules, but I need it in kilojoules, so I'm going to divide it by 1000. Now it's going to be in kilojoules per mole. Yes, just solve it out. You'll be getting the value of EA right here. Yes, correct. The second part of the question, we need to calculate the value of EA in kilocalories per mole. So I'll be writing it like this: EA is equal 2.303. Now which value of R I'll be taking, since I need to calculate it in kilocalories per mole, and we know R is equal to 1.98 calories per Kelvin per mole. So I'm going to multiply it by 1.98, or instead of 1.98, I can take a 2 multiplied by 3. Now this is right now in calories per mole. This whole equation, this value is right now in calories per mole, but I need it in kilocalories. So I'll be dividing it by 1000. Yes, I got it in kilocalories per mole. Just you can solve this out. You can get the value of EA right here. Yes. Let me know in the chat box if it is clear. This question is dusted, I guess. Yeah. Got it? Got it? Yes. Okay. Let's move on then. Let's move on to one more question. The rate constant of a reaction at 227 degrees centigrade and 427 degrees centigrade are this much and this much. Calculate it. People, it's a very simple question. Yes, few minutes back, I gave you a relation. I hope you remember that. That was log of K2 divided by K1. Log of K2 divided by K1 used to be equal to what? It used to be what? It used to be EA divided by 2.303 R multiplied by 1 divided by T1 minus 1 divided by T2. This is the relation which we derived few minutes back. Yes. Now people, at two different temperatures, I'm given with two different rate constants. At temperature T1, the rate constant is this much. At temperature T2, the rate constant is this much. Yeah. Correct. First of all, what is temperature T1? Temperature T1 is your 227 degrees centigrade, right? Which means how many Kelvin? Add 273 to it, right? It's going to be 500 Kelvin. Yeah. I think it's going to be 500 Kelvin, right? Yes. Similarly, guys, what about 427 degrees centigrade? T2 is equal to 427 degrees centigrade. 427 degrees centigrade means how much? Add just 273 to it, it's going to be 700 Kelvin. Yes. And at temperature T1, the value of rate constant is given as 0.02 second inverse. Yes. And at temperature T2, the value of rate constant is given to me as, which I'm representing by K2, it's given to me as 0.2 second inverse. Yes. Now everything is given to me. Let's kill it. So isn't it going to be log of K2 divided by K1? What is the value of K2? Value of K2 is 0.2 divided by, what is the value of K1? Value of K1 is where is it? 0.02. Yeah. 0.02 will be equal to EA divided by, it's going to be 2.303 R, right? Multiplied by 1 divided by T1. I think T1 value is given to us as 500 Kelvin. Yeah. It's 500 minus 1 divided by 700. People, can't we solve this one out? Yeah. Can't we solve this one out? Yes. Right? Everything you have. You need to put the value of R right here as 8.314. Right? This term is given. Just you need to do a bit of mathematics. That's it. So Karthik is saying it's coming as 700 joules. All right. EA, activation energy from here, is coming as 700 joules. Correct? You just need to do a little bit of calculation. That's it. Yeah. Correct? Everything is given. We just need EA. Correct? We just need EA. Rest everything is given to us. The energy of activation you'll be getting as 700 joules right here. Okay. All right. Wonderful. Then let's move on to one more question. Let me see if you can solve this one or not. Should I be giving this as homework or should I be solving this? What do you think? Because this is the last question. After this, I'm going to end the session. You want me to solve this or you'll be doing it on your own? Yes, Yashwant, I got to know, bro. You got this as homework? But people, I want every one of you to give it a try. Let me see the last thing which I told you in the last session. I wanted you to write something in the chat box. Let me see how many people have written that. Gaming has written that. Ashita has written that. Okay. Parimala, Surya. No, not this one. I need to see one more session. What was that session all about? I think that session was about the mock test. Yeah, mock test 2. Yeah. Yeah, I wanted you guys to write your score, right? I wanted you guys to write your score. Only Karthik has written the score, Aisha has written the score, Yashwant has written, Fazan has written, Priya has written, Firuk and Pavitra. Only few people have written the score. Rest, no one cared. No one bothered about it. Anyways, it's fine. It's fine, it's fine. Zia, tomorrow we'll be doing the, we'll do something as, let me see, wait for it, you'll get it in the thumbnail tomorrow morning. Tomorrow, first of all, I'm thinking to revise first of all few topics. Few topics I want to revise first, yeah, so that our physical inorganic part is done, so that we could particularly focus on organic, yeah. Okay. People, should I be doing the mole concept revision tomorrow in the form of questions? What do you think? What do you think? For few days, for 2-3 days, or maybe in this whole week, let's try to do one thing. Let's try to revise everything, whatever we have studied. What do you think? And then we start organic, yeah? So that we can, so that we can do the organic properly. Yeah, are you fine with it? Yeah, let's try to do that, yeah? Your entire things will get revised once, but the revision series will be in the form of questions only. In every session, I'll come up with 20 questions. What do you think? Everyone is cool with it? The way right now I'm doing in JE channel, I'm right now doing a marathon series, yeah, in the form of questions. So I want to do the same thing for you as well. Yeah, let's, for few days, guys, for 3-4 days, that's it. Exactly, so that only questions, that's no theory will be discussed, only questions. Whatever chapters we have done till now, in every chapter, for every chapter we'll be doing the question answer series, so that everything will remain fresh, yeah? Because I'm damn sure you would have forgotten the concepts of thermodynamics, equilibrium, I'm sure about that, okay? Redox bhi bhul gaya hoga, mole concept bhi khatam. States of matter ki baat hi nahi hai, electrochemistry will be dusted, solid state, bhul gaye honge sab, I know that. So for 3 days, for 3-4 days, or maybe in this week, let's try to revise everything so that everything gets brushed up, yeah? Okay, yeah, done. Done, guys, all right. So this is going to be your homework, and I want every one of you to give it a try and let me know the answer in the comment box, yeah? And I want every one of you to write the answers in the comment box. Okay, so people, this was the last question. With this, I'll end the discussion right here. But before ending this discussion, for the ones who joined us late, let me give you the brief idea about the NEET 2021 crash course, like what all things you guys are going to get right here. See guys, in this NEET 2021 crash course, we are going to cover your whole syllabus before your NEET examination, right? Your NEET 2021 examination. Not only the syllabus completion, there will be some extra sessions as well, by means of which you get to know how to solve the questions in lesser time by our experts like Anand Prakash Sir, the co-founder of Vedantu, yes. And at the same time, guys, there will be definitely mock tests as well as test series included over here in this crash course, okay? So wherein you can compare your ranks with other students across the country. And absolutely, it's going to be a two-way learning interactive platform wherein you can ask your doubts anytime to your master teachers, yes? Right? And people, how to enroll in this, you just have to click on the Vedantu app. After clicking on the Vedantu app, just click on the NEET crash course, and after clicking on the NEET crash course, just use the coupon code as WSCC, by means of which I'll be your mentor in this crash course as well. If you are using this coupon code, I'll definitely be your mentor in this crash course. And at the same time, you'll be getting the 20% off Okay, and after 20% off, you guys are just getting it for 8K, which is, I think, affordable, reasonable at the same time. Yeah, and people, there is again a link in the description box of the video from where you can join in as well. Just click on that link, enroll now, use the code. Yeah, let's show the bullseye together, right? And people, as I told you in the beginning also, we have started the test series alone as well. If you're fine with it, right? If you do not want to take the crash course, you can go for test series as well, wherein if you think your preparation is up to mark, you just need the mock test, you just need the test paper preparation test series you want, so you can do that as well. You can join in this test series as well. And people, in this test series, definitely it is not going to be only writing the test. There will be test paper discussions for after every test. There will be test paper discussions as well. And you just have to, there's a link in the description box of the video. Click on that link. Use the code again as WSCC. You'll be getting some discount as well, which is mentioned on your screen. Yeah. And at the same time, there is one more link in the description box of the video, which is for Telegram. Okay, click on that link, get added to the Telegram group and stay updated about the class as well. And for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time so that everyone gets benefited out of these sessions. Yes, which I always say in every session. Okay. So people, with this, it's time to take a leave. With this, we are done with chemical kinetics, right? I hope you remember how many chapters we are done with till now. We started with mole concept, you remember? After mole concept, we finished the redox, states of matter, chemical equilibrium, ionic equilibrium, thermodynamics, thermochemistry, yes, solid state, chemical kinetics. These are the 10 chapters which we have finished till now. Okay, so people, the next chapter is definitely going to be, we are going to start organic, but before that we'll brush up the things which we have discussed right here in the sessions. Okay, so I'll see you guys tomorrow again at the same time, 11 p.m. Okay, till then, you guys take care. Bye bye. God bless you all. Good night. Sweet dreams. See you tomorrow. Bye bye. Take care.